Okay, so in this video we're looking at how to work out the mean and variance of a Poisson distribution. What's really nice about this distribution is that the mean, which is the lambda in this section here, is equal to the variance, and so there's not really much working out or manipulation that needs to be done. And so if we get a question where it's kind of like work out the mean, work out the variance, if the mean approximates the variance to say 1 decimal place, then we can assume that the distribution is Poisson, especially if the events occur that the events are independent, they occur at a constant rate, and they occur at a single rate. So we're going to go through one example and it'll become a lot more clear. Okay, so a botanist counts the number of daisies, x, in each of 80 randomly selected squares within a field. The results are summarised as below. So the sum is equal to 295. The sum squared is equal to 1,386. Calculate the mean and variance, okay? And n is equal to 80. So to calculate the mean, we want the sum, which is x, over n, which is 295 over 80. And if we put this into our calculator, we get 3.69 to 2 decimal places. This is equal to the mean, so e to the x. And so for the variance of x, well, the formula for the variance is sum of x squared over n minus the sum of x over n all squared, which would be equal to 1386 all over 80 minus 295 over 80 squared, and this is equal to 3.73. Okay, so explain how the answers from part A support the choice of a Poisson distribution as a model. Well, if we look, 3.73 to 1 decimal place is equal to 3.7. And then we've got 3.69, which to 1 decimal place is equal to 3.7. So that means that the mean approximates the variance. Therefore, Poisson is suitable. So, using a suitable value for lambda, estimate the probability that exactly 3 daisies will be found in a randomly selected square. Well, we found that the mean here is equal or approximates the variance, and so we can simply use this approximation. So we can use x, the Poisson distribution of 3.7, where x is equal to the number of daisies per square, and then estimate the probability that exactly 3. So it's the probability that x is equal to 3. We can use our formula, which is that the probability that x is equal to e to the minus lambda, lambda to the x over x factorial. So if we sub our numbers into this, we get e to the minus 3.7, 3.7 to the 3 over 3 factorial. And if we just plot this into our calculator, we get 0.209. That's the basic premise. There aren't many questions in the textbook for this because obviously the mean is just equal to the variance. I'd say for all the distributions this is the simplest one, so yeah, get used to that and you'll be alright.